Okay, so the sphere is expanding in such a way that the area of any circular cross-section through the sphere's center is increasing at a constant rate of 2 centimeters squared per second. At the instant when the radius of the sphere is 4 centimeters, what is the rate of change of the sphere's volume? So then they give us the volume formula. All right, well, I'm going to draw my sphere. And so like they're kind of indicating, just kind of give it a little bit of depth here. Okay, let's say that's the center. They gave us an interesting rate of change. It's the rate of change of this cross-sectional piece. So let's say that's the radius, right? Like that there is that is increasing at a rate of 2 square centimeters per second. Why don't we just call that A? Okay, so that's A. And if you think about it, it's just a circle, right? So A is pi r squared. Okay, whatever the current radius is, that cross-section is just a circle with radius r, because it's going through the center of the circle. So the radius of the sphere will match the radius of that cross-section. All right, so I know that, so I can get a differential equation from that. And then I have my volume is 4/3 pi r cubed. All right, so let's just maybe take stock. So a rate of change I know dA dt, okay, is 2 square centimeters per second. And then the related rate, or the rate I want dV dt, right? All right, so let's go get dV dt. Okay, so that's the one we want. So up here I have that dV dt would be, so that would be 4 pi r squared times dr dt. Whereas if I find dA dt up here, dA dt is 2 pi r times dr dt. So, oh, and that's equal to 2, right? That was given. Okay, I failed to mention that we want dV dt, and the instant we want it is when r is equal to 4. So we're going to plug 4 in here. That's obvious. We just need dr dt at this moment, which we can get because dr dt, so dr dt according to this formula is, so those cancel, and I get 1 over pi times r is equal to dr dt. Okay, so what we can do is we can go plug this in as an expression right here, and then we will plug in the r value, and we should be done. So this is 4 pi r squared. dr dt is 1 over pi r. Obviously, you could plug 4 in for r now right away if you want. I'm just kind of doing some cleanup first. So like the pi's cancel, one of those r's cancel, and so we're left with that dV dt would just be 4r. So that's great. And so now I'm just going to plug in 4 for r. So at the moment I am caring about, which is r equals 4, we get 16. And so that would be 16 cubic centimeters per second. That's answer choice B.